Welcome to the Introduction to Metrics training video. This is the training video that is used for both support team training and the professional development training workshop. I'm Chaplain Dan Hall, and I'm the Deputy for Metrics and Communications to the Navy Chief of Chaplains. In this training video, I'm going to discuss the importance for the Chaplain Corps to collect and report meaningful measures and metrics. And to do that, we're going to look at three separate areas. First, I'm going to describe the Navy's need to obtain measurable data from the Chaplain Corps as a staff corps. I'm going to list several benefits to utilizing measurements to develop a well-rounded command religious program. And I'm going to describe the importance of historical information as it relates to future planning. But getting started, let's take a look at the Navy's challenge to the Chaplain Corps. What is the Navy leadership challenge to the Chaplain Corps? And to do that, let's look at a timeline of the key events that led to the release of NCMST, the Navy Chaplaincy Ministry Support Tool, and its development. Like many of you, over a period of time from about 2003 to 2009, I had developed metrics and methods and various instruments to measure the impact of my ministry and to help develop a well-rounded command religious program at the duty stations that I served in. And so the metrics and methods and instruments that are in NCMST, as well as its algorithms, started out as my inventions. Then about March of 2008, Admiral Ruffhead, who was the Chief of Naval Operations at the time, visited the Senior Leadership Symposium in Albuquerque, New Mexico. And there he challenged the Chaplain Corps to develop meaningful measures and metrics that continuously assess and report performance. And then he gave us the parameters for that system, that it should measure both internally and externally in the areas of process, program, personnel, and service. Around October of 2009 through about November of 2010, the Fleet Forces Command asked me to work with them on an after-hours basis to develop what we now know as NCMST in a part-time after-hours setting. So with them in Norfolk and myself in San Diego, NCMST was developed primarily for the fleet, or at least starting out for the fleet. Then around December of that same year, 2009, the chairman of the Joint Chiefs of Staff visited a symposium on total fitness. And in attendance were doctors and psychologists and psychiatrists, nurses, a number of people that work directly with Navy families, including chaplains. And we're talking about all forces. And there at that meeting, Admiral Mullen asked if there were any chaplains in attendance, and chaplains raised their hand. And he said, "You drive me crazy. You drive me crazy." And of course there was some nervous laughter. And you can actually Google his speech. It's found on the Chairman of the Joint Chiefs of Staff archived speech section under December 2009. And in that speech, Admiral Mullen said, "Nobody knows more about my force than the chaplains. The problems, the breadth, the depth, you name it." Then he went on to say, "But I am unable to broadly extract from the group that I think know more than anybody else about what's really going on. And I need to break that." And he actually said that twice in his speech, that part about needing to break it. In March of 2011, NCMST was brought away from part-time after-hours distance development by a couple of interested folks into full-time development by the Chief of Navy Chaplains in his office. And the collaboration enlarged to include Fleet Forces and PAC Fleet, and then later the other domains. Then in January of 2012, the Navy Chaplaincy Ministry Support Tool version 1.0 was presented to the Senior Leadership Symposium that met in San Francisco of that year. And throughout 2012, and in both PDTW settings and in 2 to 3 day intensive training, NCMST was taught to chaplains. Now, in the 1 day professional development training workshop, it was just the overview of what NCMST is. But in the 2 to 3 day course, it was detailed hands-on experience about how to not only use NCMST, but how to support others in learning how to use NCMST and learning how to support NCMST. And that's what this training is focused in on. You can glean from it the PDTW briefs, but it's primarily designed to help someone learn how to not only use NCMST, but to support others in using NCMST. So let's go to our board here for a moment and talk about other staff corps that measure. And when we think of other staff corps, the largest, it seems, of the group comes to at least my mind, and that's the medical group, to include doctors and nurses and dentists and the medical service corps itself. And then after that, of course, a large staff corps is supply. And then civil engineer may come to your mind. And then finally, the Judge Advocate General, or the JAG Corps, comes to mind. And I'd like you to take a look at this list that's on this board and answer this question. Of these groups that are listed here, which, if any, do you think does not report metrics? Does not report metrics. Now, in conducting this training, it was widely recognized that medical, of course, collects metrics. I mean, every time you go to sick call, it begins with metrics: your temperature, your blood pressure, your weight. And we see with their systems spread out all throughout the clinics and their offices that they certainly record that data. And it's a part of their training, and any chaplains and RPs that have been in the BUMED environment will understand it's a part of the whole culture to document and to record. Even our medical records are electronic now. And so we certainly know that doctors, dentists, nurses, the medical service corps collects and reports metrics. Matter of fact, you can walk into a clinic on any particular base, and somewhere you're going to find a whiteboard that'll have listed all of the units that are supported by that clinic and their current medical readiness by percentage. And then we look at the supply corps. And supply, of course, has been collecting and reporting metrics ever since John Paul Jones ordered the first 150 feet of line for his ship. And then the civil engineer group, it goes to their very nature to collect metrics, or as some people like to call it, numbers, and to report those numbers. Everything they do is based off numbers. So the civil engineers, of course, collect and report metrics. But throughout the training, there were a large number of folks who believed that the JAG, the Judge Advocate General Corps, does not collect or report, and that's more important than collecting, is the actual reporting, the follow-through on reporting, communicating to leadership, their meaningful measures and metrics. And when I asked, why do you think that the JAG doesn't collect metrics, oftentimes the answer I got back was, well, it's because they have same issues with confidentiality that we have. And that's true in many ways. They have an attorney-client relationship which enables them by law to conduct confidential communications. And those being very sensitive, it would be very important for them to, if they're going to collect those, if they're going to collect metrics, to collect it in a way that takes confidentiality in mind, and in reporting the metrics, a way that protects that confidentiality. But when you look at this list that's on this board, all of the staff corps, with the exception of the chaplain corps, collect and report to leadership their meaningful measures and metrics. We'll call them from this point forward metrics of performance or measurements of performance. They all report their measurements of performance higher up. And so they certainly collect metrics. The only one that's not on this list is the Chaplain Corps. And again, a very common theme that I heard as we went around and to 14 different sites and teaching chaplains and RPs how to use NCMST and what meaningful measures and metrics will mean to the Chaplain Corps. Oftentimes I heard back, we've been talking about doing this for 15 years and no one hasn't. No one's done anything about it. Well, for the most part, the slowdown has always been about how do we handle confidentiality. And I think with NCMST we've broke that code on how we're going to handle confidentiality. So let's start out this lesson by getting into measuring, estimating, and experimenting, and working off of the thought that anything can be measured. So to introduce this section, let's take a look at a video that many of you will remember from your childhood.
Mr. Turtle, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
I never made it without biting. Ask Mr. Owl.
Mr. Owl, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
Let's find out. 1, 2, 3.
So what I'd like to do is I'd like to go to our Blackboard and talk a little bit about this video and whether or not this kid actually has a measurement. And so with the video that we've just watched, the question that I have here is in regards to the measurement. Does this kid actually have a measurement? Does a measurement exist? And, when asking this question in our PDTWs and support team training situations, the answers really varied. Some people said, and the regular answer that I received regarding this was definitely not. A measurement does not exist with this kid. And when asked why, why is that? Some of the answers pointed to accuracy, and it's not accurate. And other answers pointed to consistency. Picking up on the fact that the kid asked about licks, and the thing that came back was licks and crunches, and so that it wasn't accurate, it wasn't consistent, and that some very astute folks pointed out that there was no standard. There's no standard lick. And the Tootsie Roll Tootsie Company, which gave us permission to use this video, showed us, when we asked them if we could use this video, how different universities around the country had developed means to answer this question. One of them, I think it was University of Michigan, actually developed a standardized liquor, something that would apply the same amount of lick each time. And it's a humorous way of looking at measurements overall, because a lot of people use this video, as that company pointed out to us, to teach exactly what we're talking about, and that is how to measure things that seem inconsistent, how to measure things when there doesn't seem to be a standard, and how to measure things and come up with a reliable or an accurate measurement. But let's deal with this thing about accuracy. I want to specifically focus in on this because many of us have heard this notion that if something is not 100% accurate, if it's not 100% accurate, then it's not accurate at all. And I want to deal with this thought about 100% accuracy to open up our conversation. And to do that, I want us to think about a test. Any kind of a test that you would take in a school-type environment. And the bottom score that you could get on that test is a 0. And the 0 would represent a total lack of knowledge, or total error, shall we say. Total error. And on the other end of the spectrum, we have 100, which would represent a total lack of error. So if you scored 100, you would demonstrate that you are a master of the subject. You have a total lack of error. And to introduce this thought, I want to look at this line and refer to this line as certainty. Okay? Certainty. Because the kid walks up to first the turtle and then the owl, because he is uncertain. So we could call it either a certainty line, or we could even call it an uncertainty line. But it measures uncertainty. The farther we go on this scale, going this direction, we're uncertain. And the farther we go this over to 100, we are certain. So uncertainty measures low, uncertainty measures high. And the kid walked up there and he had 0 certainty, or he was full of uncertainty. How many licks? He actually received 2 measurements, I'll let you know. The first one was the turtle told him he crunches it. And then the second measurement he got was 3 licks in a crunch. So was it a measurement? Yes, it was a measurement. Was it an accurate measurement? Well, we're going to refer to accuracy as measured by uncertainty versus certainty. And from this point, he walked in with a 0, but he walked away knowing that it was going to take at least 3 licks in a crunch. Now, the closer he gets to the precise number, the closer he gets to 100. But here lies the real problem. Is there anything such as a 100% accurate number? Does 100% accuracy exist? Well, let's think about it in regards to the Chaplain Corps. And when we think about certainty as it relates to the Chaplain Corps, we currently report no meaningful measures and metrics that are consistently measured by a standard to higher leadership. So it's easy to say that our uncertainty is on the low end of the scale. Will we ever get to the point where we are reporting absolutely all meaningful measures and metrics, where our meaningful measures and metrics totally lack error? Is there such a thing as that? Well, folks who deal with mathematics, statistics, measurement will tell you that in the field of measurement, there is no such thing as 100% accuracy. Matter of fact, a British philosopher about 150 years ago referred to it as precision and said there is no such thing as precision. And any man who would tell you that he's 100% precise is an imprecise man. So how far along this line are we shooting for? Are we shooting for 100%? Well, we want to definitely get close to the certainty line. But just to let you know, we're looking to get to that 90% confidence level, which is represented in being called a confidence interval. And we'll deal with that as we go into the lesson. But the kid's measurement certainly did walk away with a measurement. It certainly was nowhere near the 90 or 100 area. It was nowhere near the 50% mark. It was nowhere near a 10% mark, but it was better than he started out with. Let's think about it one more way before we go back to our presentation. In ancient times, things were measured by the span of a hand or the length of a forearm. And the question then arose, well, whose forearm? And the answer was, well, it's the king's forearm. Well, that's okay, unless you have one king whose forearm is massive, and then the next king, his forearm is shorter. Then there goes your standard. But over a period of time, we went from the span of a hand to the length of a forearm to distance measurements that we'll talk about in a little while. Let's go back to our presentation. So going back to our presentation here, and the thought that I introduced earlier, and that is that anything can be measured. When I talk to folks about that and say that and recognize that in the Chaplain Corps we're definitely measuring intangibles, but that intangibles can be measured because anything can be measured, I'll often get some pushback saying, well, there are things that cannot be measured. And I'll ask, well, name them. And the feedback is something like love. Love can't be measured. And those who are focusing in on the military aspect of what we do, they'll say, well, morale cannot be measured. And I challenge that thought by saying it certainly can be measured, because anything can be measured if it can be observed. And we are certainly in the observation business, and therefore what we do and what we see can be measured. So when we're looking at something that we have to measure and we consider it an intangible, I need to ask this question: can it be observed? You say, well, why is that important? Let's go to the blackboard and let me show you. And so when we're talking about things that in the military seemingly cannot be measured, oftentimes what I'll hear is someone say morale. Morale cannot be measured. And in order to prove this a false notion, the question I like to ask is, well, can you see it? Can you see good morale? Can you see bad morale? Can you recognize it? You know, what does it look like? Can you recognize morale when it's positive or when it's negative? You know, what does it look like? And military people should and oftentimes answer back, well, they certainly can recognize good morale. You know, when I ask them, you know, tell me about good morale, they say, well, it could look like a higher work production. People come to work, they work hard, and they work the long hours, and they're willing to do that. Some folks look at good morale and they say that it's it reflects in fewer legal problems. And, you know, fewer captain's mass, fewer problems with authority, and so forth. And when I ask them, well, describe to me what bad morale looks like, and could you recognize it? And they say, oh, wait, certainly. You know, it could be an increase in legal problems, you know, just the opposite of what we saw before. It could be an unwillingness to work hard, or you know, an unwillingness to follow authority or to trust authority. And so it's interesting when I'm asking military people to tell me about morale and hearing their answers. It reminds me of a book that I read entitled Morale, and the author was a gentleman by the name of John Gardner. Now, John Gardner was a retired, or I don't know if he was actually retired, he was a Marine Corps officer, a former Marine Corps officer. He advised 4 presidents, and on both sides of the aisle. So he was a presidential advisor, and he wrote some great things on leadership and so forth. But one of his greatest works is a small work entitled Morale. And in morale, John Gardner listed 15 elements that point to good morale, and or how you could measure morale. And oftentimes, when I hear other folks describing morale, they'll come across they'll mention John Gardner's 15 elements, having never read the book, because truth is truth, and the proving my point that they certainly can recognize it. And so, if you can observe this higher work production, can work production be measured? Well, the answer is yes. Can fewer legal problems be measured? Yes. You can measure the opposite of that when they go up. And you can actually measure whether it's numbers of counseling cases or interviews or whatever. You can also measure people who will tell you that they're not willing to do extra for the institution. And so morale is certainly something that, although it seems intangible, that we can measure. And if we could do this to morale, we can name other intangibles. The great one of love. Can you recognize it? What are some of the elements that you would say indicates great love? And we know that there's been other authors who have taken this topic and have looked and actually put numbers to things that in love could be measured. Let's go back to our brief. So the question is, can it be observed? And if it can be observed, then we can break it down into its components, or some of the components that we can recognize that are fairly consistent, and actually measure those things. Second, when we're dealing with anything can be measured, we have to answer the question, what is known about it already? And let's go back to our topic of morale. Much is known about morale, not only by people who have just been in the military for a while, but there's been many, many books and research written on morale. So a lot is already known about the topic. And so you ask the question about this intangible. What do we already know about it? Which brings me to something I want to point out in this training, and that is the Chaplain Corps knows more than it thinks it knows. And that's the message that Admiral Mullen was sharing as well. You know more than you're sharing. And oftentimes we think, well, we don't know that for certain. But in actuality, we know a lot about the topic, tone of the force, morale, than we think that we know. You know more than you think you know. And then finally comes the big question about measuring anything, and that is, does it matter? Does it really matter, the thing that we're talking about? If it matters, then let's measure it. If it doesn't matter, then let's not measure it. And that's something you'll see later on as I point out that there are some things in the Chaplain Corps that we may think is important to measure that down the road we'll discover it's really not as important as we thought. Let me introduce you to 3 of my measurement heroes. The first one is this gentleman, Eratosthenes of Cyrene. He teaches us that you can measure by observation. And this leads right off to what we were talking about. Now, Eratosthenes was an interesting character, lived about 250 BC, and was the librarian at Alexandria, Egypt. And if you remember your Western civilization classes, you'll remember that the library at Alexandria was the Wikipedia of the day. Any great scientific discovery, any great medical discovery, any poetry, any philosophical theses, if they were written, they were copied and sent to Alexandria. And Alexandria, the library there, became the repository for world knowledge. It's said that when the library at Alexandria burned, that more was lost in knowledge than has been accumulated since. And it's a large statement, just pointing to the importance of the library at Alexandria. But Eratosthenes was much more than a librarian. He was a mathematician, he was an astronomer, he was a poet, he was a geographer. If you've ever studied prime numbers, his prime number sieve, which is still used to this day, certainly makes prime numbers understandable. The fact that we divide our calendar into months, weeks, and days can be attributed to Eratosthenes. Certainly, the names of the months and the lengths of the days in those months have changed to please the whims of Roman emperors, and we've had to adjust a little bit more for accounting for leap years. But the basic structure of the calendar even was something that we can attribute back to Eratosthenes. He referred to himself as the friend of knowledge. He loved to learn. He loved to think about things in ways that other people did not think about it. And so his primary thing that we can attribute to Eratosthenes was his ability to think critically and to observe what was going on around him. And so in measuring via observation, critical thinking skills and observation skills are a premium. One day it occurred to Eratosthenes to ask about an impossible measurement, and that was, how big is the earth, and how can it be measured? Now, Eratosthenes asked this question to many of his friends, and the responses that he received back were very similar to the types of responses people share when they think that things today are impossible. For example, Eratosthenes was told by one of his friends that if you were to travel the entire earth and could live 100 lifetimes, you would not be able to measure how big the earth is. Others were very pragmatic in their answers, saying that we basically don't possess the technology, as we would call it, to measure something as large as the earth. So Eratosthenes looked at it another way. What is known about the earth? Now, contrary to popular opinion, the Greeks believed that the earth was round, and they had some basic observational evidence to prove that. They looked at the moon and they saw that the moon was round. They looked at the sun, they saw that the sun was round. Eratosthenes noted in discussing this that ships would leave the harbor and they would dip over the horizon, which demonstrated that the earth possessed a curve. Just what was the size of that curve? He didn't know, but he did know that it was round. Then second, he thought about, well, what can be measured? What can be measured? By the time Eratosthenes came around, the span of a hand or the length of a forearm had long since been forgotten as standards of measurement. The Greeks had developed a standard of measurement that they referred to as the stadia, and they were very, very accurate in their ability to measure great distances with a measuring instrument that they called a stadia. We have our mile. Europe has its kilometer. Greeks in those days had stadia. And then, what would the result be with that? Well, as I mentioned, Eratosthenes wasn't worried about the math. He was a great mathematician, studied under some of the greatest mathematicians of ancient Greece, but he could figure out the results. One day, in his library, Eratosthenes came across an interesting document. And that document said that in the southern city of Syene, south of Alexandria, in the interior of Egypt, there was a well, and an unusual phenomenon happened once a year in this city of Syene in regards to its well. The document said that on the summer solstice, when the sun was at its zenith, you could see your reflection in the bottom of the well. Now, the summer solstice is what we know as the first day of summer, or June 21st. So on June 21st, when the sun was at its zenith, or high noon, as we would like to say, you could look down into that well in the city of Syene, and you could see your reflection. Now, the document noted that this was an impossible feat for the rest of the year. And it also noted that in the city of Syene, when you could see your reflection at the bottom of the well, that none of the straight edges, like the sides of buildings or columns, cast a shadow. Now, this struck Eratosthenes as interesting because he had been in Alexandria for summer solstices, and he had observed no such phenomenon in Alexandria. He noted that in Alexandria, shadows were cast. So the question we have to ask, and Eratosthenes asked as well, was, what was known about this? What was known? Well, Eratosthenes and the Greeks of that day knew that the sun cast parallel lines on the earth. And so as Eratosthenes thought of this, he noted that the same sun rays that hit the tower at Alexandria cast a shadow, whereas those sun's rays did not cast a shadow in Syene. So what was known? And what could be measured? Well, there were several things that Eratosthenes knew he could measure. One, he could measure the distance from Syene to the tower at Alexandria. And second, using an instrument that 8th graders know how to use, called a protractor, he could measure the angle of the shadow cast off the tower at Alexandria. And so he hired a friend to do a stadia measurement between that well in Syene and the tower at Alexandria. And on the next summer solstice, Eratosthenes himself measured the angle of the shadow cast off the tower at Alexandria using a protractor. And what was the result from his measurements? Well, let's go to our board and take a look. First thing that Eratosthenes noted was that there was a 7.2 degree angle of shadow cast off the tower at Alexandria. Now, the Greeks had long since taken a circle and divided it into 360 equal angles. And we follow through to that this day, obviously. So he divided 7.2 into 360, and he came up with an answer of 50. So he knew then that, also from his friend, that the distance between Syene and Alexandria was, once we convert stadia to our modern day miles, 497.1 miles. And so from his angle of the shadow and the distance to Syene, he knew that Syene must be 1/50th of the circumference of the earth. Took that 7.2, took the 360 degrees that are in a circle, divided it by 7.2, the degree of angle of shadow, came up with 50. He knew it had to be 1/50th of the circumference. So he just simply multiplied the distance between Syene to Alexandria by 50. And his answer was 24,855 miles. The correct answer? 24,901.55 miles. Do you see the difference between those numbers? It's minuscule. Some have said he was off because he didn't know that gravity pulled on the equator of the earth, making it slightly bulge. But regardless, Eratosthenes was 98 some odd percentage points correct. Columbus, as compared to Columbus, was only 75% correct. A better answer wouldn't be available until the French measured the world in 1799. Now, for those who would say if it's not 100% correct, it's 100% wrong, would have to answer to Eratosthenes. Now, look at the difference between the two, Eratosthenes and Columbus. Columbus had Eratosthenes' math. He had Eratosthenes' findings. Why was he only 75% correct? Well, it's an argument of standards. The Italian and the Portuguese navigators of the day believed that the modern-day Greeks had overestimated the distance of the stadia. And because of that, they believed that the stadia was about 3/4 shorter than the modern Greeks of the day believed. And the modern Greeks of his day felt he was wrong. And they were right. They did know from ancient times what the length of a stadia was. And so Columbus, thinking he was going around to the continent, the subcontinent of India, found that he was only 75% correct. Let's take a look at our second measurement hero, and that was an Italian physicist by the name of Enrico Fermi. Enrico Fermi was born in Italy and was the 1938 Nobel Peace Prize winner for physics. He fled fascist Italy and came to the United States of America, where he was hired by the University of Chicago, where he taught physics and actually developed the first nuclear reactor under the squash court at the University of Chicago. But he also worked on the Manhattan Project. And that was the project where the first atomic device was created. And one of the reasons Enrico Fermi was brought on was not only his understanding of physics and nuclear power, but also Enrico Fermi had a unique system of rapidly developing approximations. And better yet, he could teach that method to others. Enrico Fermi actually produced the very first measurement of the yield of the very first atomic device within minutes after it went off. And he was more accurate than those who delayed their findings up to a week afterwards. So Enrico Fermi was a brilliant man who could teach approximations extremely fast. His method of doing so to this day is known as Fermi problems. You could Google the word Fermi question or Fermi problems to this day and still see some of the questions that he would ask his students before he would begin a regular class time. So imagine coming into Enrico Fermi's physics class at the University of Chicago expecting to hear something about physics, and the class starts out with this question: how many piano tuners live in Chicago? Of course, he was talking about the 1930s in his day. How many piano tuners? And people would throw their hands up. One, what does it matter? And two, I'm not interested in this. But Fermi wanted to teach them how they could take an unknown and, based off information that they already know, quickly develop the correct answer in an approximation. So here's how he taught them how to estimate this. First, he had them ask a question as simple as, what's the population of Chicago? Now, again, he was talking about the 1930s, and he would encourage people to think of it in three lines: an upper limit, a lower limit, and somewhere around the middle. And so someone would maybe say, oh, it's 1 million. And another person would say, no, it's more like 5 million. And so they would shoot it down the middle and say 3 million. Now you could do the math on either side of that, but they came up with the answer of, well, there's 3 million people living in Chicago. So then he asked, well, how many people live in each household? And a clue for that is that there has to be at least one person in a household to make it a household. And so they came up with an answer of 3. Some households are just 1, lower limit. Some households might be as many as 5 or 6, upper limit. But on average, let's say 3. So they came up with 3 people live in a household. Then he asked them to figure out the answer to this question: how many households do you think have pianos? Now, 3 million is an awfully large number to get your mind around. And so instead of thinking that way, he oftentimes would teach them to think about things by a factor of 10. So, up to in tens. So instead of thinking about it in 3 million, how many pianos are in 3 million homes, ask this question: out of 10 homes, on average, how many of those homes would have a piano? Would it be 1 out of 10, 2 out of 10, 3 out of 10, 4 out of 10? And so they discussed this back and forth, and they came up with an answer that about 2 out of 10, or 1 out of 5, which is 20%, have a piano. And so then he would ask this question: how often do you think they tune their piano? Now, pianos really haven't changed from Enrico Fermi's day to today, and most people who own a piano will tell you that you should get it tuned about once a year. Now, if you bang on it really hard, you might want to tune it twice a year, and if you're negligent, you might tune it only once every 2 years. But the answer typically is you're going to tune a piano 1 time per year. Then he asked them this question: how many pianos do you think a piano tuner can tune a day? And that's an easy question to kind of break down. You know, you have to think about the guy has to pack his gear up and travel from place to place. Pianos can't be transported to them, and you tune a piano in place. And so they came up with an answer of 4 pianos per day. And then finally, he would ask them to think about, how many work days do you think a piano tuner works in a year? Now, they had a lot of discussion. They came up with an answer of 250 days. Let's take this to the board and see how the answers work out. So we see we have 1 million households in Chicago. 3 million population of Chicago divided by 3 persons in a household is 1 million households in Chicago. And then, remember, they figured that 2 out of 10, or better expressed as 1 out of 5, of those households have pianos. They determined that there were 200,000 homes or households that have pianos in them in Chicago. And if they have their pianos tuned once per year, we can forward that number on and say 200,000 pianos need tuning each year. And then they figured a piano tuner can tune 4 pianos a day, considering in an 8-hour workday that the piano tuner can tune 2 hours, a piano in 2 hours. So in an 8-hour workday, divided by 2 hours per piano, we see 4 pianos a day can be tuned. And so when they take that number, 200,000, and divide it by 4, they come up with 50,000. Then they look at how many work days per piano tuner. They come up with 250. They took the 365 days. They separated from that, subtracted from that, I should say, the weekends, the holidays, and some vacation time, and they came up with 250 days per year. And when you divide 250 by the 200, you come up with the answer of 200. So they said 200 piano tuners lived in Chicago in the 1930s. The correct answer, which Fermi always had available, was 185. 185. Now that's only 15 away. That's less than 10% off of the estimate. So let's talk about the Fermi process in detail. If you want to practice Fermi's method of coming up with quick and accurate estimates, ask specific questions, but ask questions that are simple, and ask questions using upper and lower limits. Then you could do the math on each end of that and still come up with a reasonable estimate. And then check for sanity. For example, with the question of what's the population of Chicago? I asked that question in one of our training evolutions, and someone who obviously had no clue said 1 billion. There's 1 billion people living in Chicago. So if you want to practice the Fermi process accurately, check your answer for sanity. And so finally, just then add it up. Now, the lessons that we can learn from Fermi are these. You know more than you think you know. You do know more than you probably give yourself credit for. And where your uncertainty lies, let's say, what's the population of Chicago? We live in a day where anyone with an iPhone or an iPad or an Android, if their battery is still working, can quickly find out what's the population of Chicago by simply Googling it or going to the Census Bureau. So where your uncertainty lies, that's where you can buckle down and work on the question more in detail. And so when you ask yourself questions about things that you already know. And this is a great process for using to determine quick estimates, accurate estimates before big projects. The benefits of this process are that it builds critical thinking skills. It doesn't require high math skills. If you'll remember back, we just used the basic math operators of addition, subtraction, division, and multiplication. And it's very quick. Fermi will be the first to tell you that. The bottom line walk away from the Fermi process, in addition to you know more than you think you know, is that estimates oftentimes will get us into the general area. Now, this always reminds me of a question that Admiral Burt shared with the Chaplain Corps during the PDTCs and PDTWs introducing the professional naval chaplaincy concept. He was asked by the CNO, how many chaplains do you need? And he said he answered the CNO, as many as you'll give me, and then instantly regretted his answer. But imagine if he would have used Fermi's process and came up with a rapid estimation using an upper bound and a lower bound and said something along the lines of, I need at least 850, but I certainly could use 1,200. Estimates, especially estimates that are bound between upper and lower limits, can get you into the general area, and oftentimes all you need is that. My third measurement hero is a young lady by the name of Emily Rosa. Emily Rosa was 9 years old when she entered the science fair. She won the science fair, by the way, and she had to write a document about, or a paper about, how she came up with the idea that she had in the science fair. And so she did. She wrote the paper as a classroom assignment, handed it to her teacher. Her teacher was so impressed with it, her teacher handed it to the principal, who was so impressed with it, who handed it to the school district, who was so impressed with it, who handed it off to the state Board of Education, who was so impressed with it, sent it along to the Journal of American Medical Association, who published it, making Emily Rosa, at 11 years old, the youngest published peer-reviewed author in the history of the world, a distinction that she holds to this day. I want to discuss what Emily did to get to the point of where she was at. Emily was fascinated by anything to do with the force. And Emily followed her mom one day to a take your daughter to work opportunity. And her mom was a nurse, so she got to go to the hospital to see what her mom does during her workday. And while there at the hospital, Emily saw something that made her say to herself, that's what I want to do my science experiment on. That's what I want to enter the science fair with, that particular thing. And Emily's item was, can someone detect a human energy field? And so Emily teaches us that you can measure while doing something. And again, Emily's item was how to detect and measure a human energy field. And if you can do this, if you can measure it, can it be repeated?
Watching voodoo Here, Priestess Jones says she's pulling out someone's negative energy and shaking it away. I'm struck by how similar it is to what's being done right now in mainstream American hospitals. It's called therapeutic touch, and it's practiced in hundreds of medical centers, even during surgery. In Connecticut, Nurse Ann Miner does therapeutic touch on Lisa Brackett to help treat her leukemia.
Tremendous heat coming from your heart center. Do you feel it?
Yeah, I do.
The nurse supposedly feels without touching from 3 or 4 inches away, feels the defective energy pouring out.
I can feel where the energy is balanced and where it's not balanced. I can feel where it's intense. I can feel it's depleted.
Then she says she channels the healing energy of the universe through her hands to you. There's no scientific proof that this works, but the patient says that doesn't matter.
I don't need explanations because I have faith in the process. That's a really wonderful thing when you feel helpless, terrified, when you're given a diagnosis, like I was.
It's hard to argue with satisfied patients. But 2 years ago, a 9-year-old girl in Colorado thought that for her 4th grade science project, she'd put therapeutic touch to the test.
Today I'm going to test you on how well you can feel the human energy field.
Emily Rose's test was simple. She asked practitioners of therapeutic touch to feel the energy from her hand. But first, she had them put their hand through a towel and piece of cardboard so they couldn't see where her hand was. She didn't ask them to heal anything. She just asked the most basic question.
Tell me which of your hands you think my hand is over.
Left.
Again and again, touch therapists failed the test.
Left.
Amazingly, they kept volunteering to take the test. And even when they failed to do better at picking the correct hand than they would have done flipping a coin,
right,
their faith in their skills was not dimmed. Okay. This woman guessed right only 3 times out of 10.
How do you think the test went?
I think it went very well.
Okay, you got 1 right. Sorry. I got 4.1 for an average of correct guesses. 5 is chance, and they got below chance.
And so Emily's experiment, trying to detect the human energy field, and by the way, this video is not my demonstration of it here is not a commentary on therapeutic touch, but on Emily's methods. Emily's measurement test is a great example of how we can measure something while doing something. Let's go to the board and take a look at Emily's math. She had 28 therapists who each received 10 times or 10 chances or 10 opportunities, however you want to call it, 10 opportunities to detect her human energy field. That's 280 attempts. Of that, 44% of the time, correct identifications were made. Now, Emily made a statement at the very end that chance is 50% and they got less than chance. Her thesis was that uncertified therapists would have done as well. Now, what's interesting about this process is that being a peer-reviewed author means that her findings have been put to the test time and again. And consistently, it's been shown that Emily's math is right on the mark. Matter of fact, Emily did this once when she was 9 years old, then she did it again when she was 11 years old for this video that you saw. The first time she did it, she had 4.1. The second time around, she had 4.4. And other people who have come along and did the same test are finding the same range of numbers in their findings. Matter of fact, this experiment was tested even by people like Mythbusters and so forth. So the experiment process that Emily reminds us of is that when you're going to measure by experimenting, be random, use randomization, and use controlled conditions. Emily used controlled conditions. And she teaches us that even small sampling is sufficient. We don't have to measure every, she didn't have to measure every touch therapist in her state or the nation to get an accurate number. she only had to measure a representative sample and also eliminate bias. And I want to talk about how, for example, Emily eliminated bias. She eliminated bias when she was choosing which hand she was going to put her hand over. What the video doesn't show us is that before she would choose to put her hand over someone's right or left hand, she would flip a coin. And one side of the coin would mean that she puts her hand over their left, and the other side would mean she puts her hand over their right. And so eliminate bias. We're going to talk more about that in a minute. And then finally, just use simple observation. Just simple observation. It was a binary question, yes or no, right or left. And simple observation is the key to measuring via experimenting. And then just ask basic questions, as Emily did. Is my hand over your right hand or left hand? Now the lessons from we can glean from Emily's experiment, which applies to all experiments, is to refuse to accept retroactive excuses. Now, although she was a young lady at the time, Emily became the focal point for criticism from people who felt that this was an attack on this process. Emily asked the question, for example, can you detect my human energy field, to each of the participants before they went behind the wall in the controlled condition. Each of them indicated that they could detect her human energy field, and therefore, by her protocol, they were then allowed to go behind the wall and to try to detect her human energy field after putting their hands through the right and left hand holes. So refuse to accept retroactive excuses. And with that, let me say this about measurements and metrics, especially as they're going to apply to the chaplain corps. The numbers are what the numbers are. And then repeat the experiment. If your methodology is good, you should find that your next set of answers will be in an acceptable range from your previous set of answers. Repeat the experiment. And then, of course, keep in mind low budget is best. We'll all say amen to that. And the KISS methodology. But the big walk away from Emily's observation, her experiment by doing, is her measuring by doing, is that things must have observable consequences if they matter at all. If something matters, it ought to have an observable consequence. And I believe that everything we do as chaplains and RPs has an observable consequence. Finally, let's look at the value of information, and then we'll conclude this lesson. And work from the precept that information has value, and we should understand the impact that value has. Here's a graphic that comes from a magazine entitled Christianity Today. And in the magazine, they take a look at a congregation in a community, and they ask the question, what's the value of that congregation to the community? And look at the elements that they have there. They're specifically talking about those things that impact have an economic impact on the community, like, you know, someone does the landscaping. This congregation probably prevents divorces through counseling. It helps people get off drugs or alcohol. It helps to reduce crime. It encourages volunteers. It produces income from the community because members go out into the community and spend money for each visit during the week. So it brings us to ask this question: what's the economic value of chaplains and RPs? And what areas do chaplains provide positive economic value? And what would that amount be? For example, we asked that question of the commanding officer at the submarine school in Groton. And he shared that a trained submariner had a value to that community of $145,000. And that's just not a number that he pulled out of the air. He knows how much does it cost once someone comes from basic training to the submarine school, by how much we pay the instructors, how much the buildings are worth, how much the equipment is worth for the length of time that they're there. We divide that across the people that we're training, and the answer is $145,000 per trained submariner. And then the security clearance that they receive that prepares them to go to one of the submarines, that security clearance costs $29,000. And if you take a look at the cost to recruit anyone across the Navy, now obviously some people are very cheap. It doesn't cost anything practically. They know they want to join the military. They know they want to join the Navy, whereas other people have to be convinced through advertisement, through discussions with recruiters, through pamphlets that they read. But when we look at the overall cost per person, that cost works out to be $2,200. So that CO equated a value for anyone in his staff, including his chaplain, that could help a submarine student stay in school and finish the track that they had started down, a value of $176,200 per student. And he made the point that his chaplain did that each month for at least one identifiable person, if not more. That's $176,200. And so the value of the information of how that occurred, what was the age of that student, what was the gender of that student, what was the issues facing that student, that information has value. Let's think about counseling couples, marital counseling. In Southern California, the cost of a divorce proceeding is around $20,000. That's on average. Some is more, some is a little bit less, but on average it's $20,000. And if you consider that TRICARE, for example, funds 12 sessions up to $100 per session for marital counseling, that's a $1,200 counseling value, a $20,000 court saving value. So each person, each couple I should say, who is turned away from following a path that leads toward divorce, has an economic value of $21,200. And we could do the same thing for a UA student. Apply 12 counseling cases. Take a look at the fact that training support centers spend about $4,500 per week for someone to be UA, with all the staff that handles UA personnel, with the time that the staff puts in and the effort, and the loss of a rating. For example, take the STG rating. The loss of a rating has a value to it. Here it's reflected as the STG. Apply that $2,200 recruiting value, and we see that helping a sailor not go UA, or to return from a UA status soon enough not to lose that rating, has an economic value of $32,900. And this is a graphic that CNIC chaplains, I'm sure, will recognize. This graphic comes from the Labor Department, where they have applied an upper and a lower range to the value of volunteers in their state. So, for example, if we were to take a look at the state of Virginia, where the value of a volunteer is $22.50 per hour to $23.29 per hour. Or in California, where it's just slightly higher at $25.22 to $28.52. Now, our RP community has mastered the art of getting people to volunteer. So if we take 4 volunteers, let's say in California, and they produce 4 hours of community volunteering. That's the economic impact to the command of $3,417.60. Information has value, and it is possible to know what that value is, not just through estimation, but through known published materials, known accounting methods. We can figure out what the information that we're gathering, what's the economic value that is of chaplains. Now, there's only 3 reasons why information has value. First, that information reduces uncertainty. There's our key word again, about decisions that have economic consequences. Should the chaplain corps have 850 chaplains or 600? That information, the required to make that decision, needs to have a reduction of uncertainty, because that decision is going to have an economic consequence. Then, second reason why information has value is that information affects the behavior of others, which has economic consequences. What would happen to you, young sailor, if you go UA? Well, loss of rating, loss of funds. Providing that information affects the behavior of others, which has economic consequences. Same, we can see this with not only our UA example, but also our divorce example. And then finally, sometimes information has a market value all its own. And there's some great stories to tell about that, but we'll save that for another time. So if we knew the value of information, it would affect what we measure. Some of the things that we've never measured before, we would begin measuring. And some of the things that we measure now, we may ignore in the future. So as we go, our initial opportunity of measuring things in the Chaplain Corps may seem like 3 licks and a crunch, but we're going to consistently, over time, reduce uncertainty. Our measurement processes are going to get better, and we're going to find out and be able to report to authority not only what is the economic impact of chaplains and RPs, but also that tone of force information that was critical to leadership, as Admiral Mullen discussed. So if you have any questions, I want to encourage you to email me at dan.hall@navy.mil. In this lesson, we looked at the challenge to the Chaplain Corps to communicate with leadership via meaningful measures and metrics. 3 key methods to developing and measuring items, which is via measurement by observation, estimations, and experiment. And the value of information, what the economic impact of the Chaplain Corps would look like. Again, if you have any questions, please email me at dan.hall@navy.mil. I want to thank you for your time and encourage you to continue on to the next lesson. Thank you very much.